So friends, today we have a bulk-necked oven. The circuit breaker tripped, so I carefully disconnected the faulty lower heating element, just so I could safely keep using the entirety of the oven temporarily for now. Then the rear one broke as well, after a while. Now the oven only heats with the top element, but now it's getting a bit too stressful, so we need to repair it again. There are 2 screws up here and 2 screws at the bottom. Of course, you have to unplug the power cord when you do these kinds of measurements. Otherwise, you could damage your multimeter, or you might get a little tingle in your belly button. Let's take a look and loosen the screws up here. And up here on the side. So, we have 3 more screws on the side here, plus that one. Now we'll take a measurement of this first so we can see exactly why it's broken. So it's actually quite beneficial that I disconnected the lower retaining coil up here. I just wrapped a cable tie around it so it doesn't get any power anymore, because everything was sparking a lot, and that's why I disconnected it here. It goes down here and then directly onto this. So now we definitely want to measure everything here. To do that, I'll pull these off now. Once and twice. If you measure it now, the heating coil would be fine. But what shouldn't happen is that if I touch the housing, it also shows a connection. So there are 2 types of faults with heating elements like this. One is an insulation fault. With an insulation fault, as the name suggests, the insulation is defective, and here current may possibly be discharged through the housing to ground, which of course causes the circuit breaker to trip. Of course, you can measure it like we did here, and you really get your 51 ohms, so you think, oh, that's fine, I don't have a problem. But then you measure against the housing, and suddenly you also have a resistance across the housing, which of course should not happen. Right here on this exact spot, as we can see. Now we go here. Continuity. So it's connected. If I touch this now, it beeps. If I now touch up here, nothing. The OL on the multimeter means open line. That basically means infinite resistance. So in Germany that means no current is flowing. Inside there's a wire that goes all the way around, and if the wire is broken, you have no resistance, you can't, and then you know, okay, the thing is broken. Now it's showing a connection here, and it is beeping now to indicate that. With this multimeter, if the resistance is under 30 ohms, it gives off a beep right here to signal the connection. Now we'll do the same thing to the housing. So now of course we have no connection there. That's how it should be. Now let's try over here again. There's nothing there. So, and with that we know that the lower coil and the coil in the middle is completely broken, and the upper one is in good working condition. But I already knew that beforehand, since I was only baking with the upper coil anyway. You can easily perform this measurement on these same heating elements. It really doesn't matter if you are doing it on a washing machine, a clothes dryer, or like we have here on the oven. The way the whole process works is going to be exactly the same for any of them.